Hey everyone, welcome back to the channel. Today, we're diving into one of the most essential concepts in physics. Forces, their types, and how they shape the world around us. Whether you're a student, a curious learner, or someone who just wants to understand how things move, you're in the right place. Let's start with the basics. What exactly is a force? In simple terms, a force is a push or pull that can change an object's motion. The SI unit of force is the Newton, which is defined as 1 kilogram per second squared. Why is force important? Because it's fundamental to how the universe works, from how cars move, to how structures stand, to how the planets orbit. A force can change the shape of an object, start or stop its movement, or even change its direction. Forces fall into two major categories: contact forces and non-contact forces. Contact forces need physical interaction between objects, while non-contact forces act even when objects are not touching, like gravity or magnetism. These forces are part of our everyday life, whether it's walking, driving, or using electronic devices. Let's break down contact forces first. These include frictional force, resists motion between surfaces; tension force, force transmitted through strings or cables; normal force, support force from surfaces; applied force, any force you apply manually or mechanically; spring force, restoring force from stretched or compressed springs. Friction is the resistance to motion between two surfaces in contact. There are different types. Static friction keeps objects from moving when a force is applied. Sliding friction acts when surfaces slide past each other. Rolling friction is seen in wheels or balls. Fluid friction is the resistance in air or liquids. Friction is why we can walk, stop cars, or write with a pen. Normal force acts perpendicular to a surface. If you place a book on a table, gravity pulls it down, and the table pushes back with equal force. This is crucial for structural balance in buildings and bridges. Tension is a pulling force transmitted by ropes or cables. Think of suspension bridges or elevator cables. Tension keeps everything hanging safely. Engineers use it in many designs, especially in load-bearing systems. An applied force is any external force. For example, pushing a cart or pulling a drawer. A spring force, on the other hand, is what you feel in a trampoline or a car's suspension system. These forces are central to machinery and mechanical designs. Now let's explore non-contact forces, forces that act at a distance: gravitational force, attraction between masses; electromagnetic force, between charged particles; nuclear forces, forces that act within atoms. Gravity is what keeps us on Earth and the planets in orbit. Its formula is F equals G times m1 times m2 divided by r squared. It explains tides, falling objects, and why we weigh what we do. This force governs electricity and magnetism. It's the reason magnets stick, lights turn on, and signals travel wirelessly. It powers devices like MRI machines and maglev trains. Nuclear forces are incredibly powerful. The strong nuclear force binds atomic nuclei, while the weak nuclear force is responsible for radioactive decay. They're crucial in nuclear energy and medical radiation treatments. Force is everywhere. In transportation, it helps design fuel-efficient cars and aircraft. In engineering, it ensures buildings are safe. In robotics, it's used to design precise movements. Even in sports, it improves equipment and athletic performance. In daily life, you use forces when operating appliances or simply walking. In advanced tech, forces are behind nanotechnology, space exploration, and renewable energy, like wind turbines and hydropower plants. To sum it up, forces are either contact or non-contact, and they play a critical role in how everything around us moves and operates. From basic machines to the most complex technologies, understanding forces unlocks a deeper understanding of the universe. If you found this video helpful, don't forget to like, share, and subscribe for more science content. Drop your questions in the comments below, and we'll see you in the next one.